So lesson 3 of the area of a region between two curves. So if you didn't watch the first 2 lessons, make sure you go back and watch those first. So let's start with number 1 here. We have to find the area of the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. So this one's a little different because normally we're given y equals, and this time we're given x equals. So before I do anything, I'm going to solve these for y so I can use my calculator to show me what the graph's going to look like. So over here, I'm going to subtract the 3 over. And then I'm going to divide by the negative, so negative x plus 3 equals y squared. And I'm going to take the square root, and I'm going to get a plus or minus when I do that. Over here, if I solve for y, I get x minus 1. So I'm going to go to my calculator. I'm going to graph those in. That's 3 lines because of the plus or minus. So in line 1, I'm going to do the positive square root of negative x plus 3. In line 2, I'm going to do the negative square root of negative x plus 3. And then I've got x minus 1 as my third line. Okay, so we're going to get a sideways parabola, and we get a straight line. So I'm going to draw a sketch of the straight line. That's the easy one to do. So it starts at negative 1. I've got a slope of 1. And I'm going to be wanting to find where these 2 lines cross each other. So I'm going to do my second trace intersect. So on my calculator, I've got the color codes here. I want to go between blue and black to find that first point of intersection. So that one crosses at 2, 1. So I'm going to plot a point there so I know that. And then my red and my black line, so the lower parabola and the straight line, I'm going to find where those cross. Sometimes it takes you a little bit to get the cursor to be on the right line. So that one's at negative 1, negative 2. So when I draw a sketch of my parabola, I want to make sure I cross through those lines. And I'm going to shade the region that's bounded, which is the top part of that sideways parabola. Now, there's 2 ways we could actually find the integral or the shaded region for this graph. I could do top minus bottom. Now, the issue that I have here is that the purple line's on top until we get to this point right here. Then this top half of the parabola is on top. So I'm going to show you 2 different ways to do this. So if I had to do it that way, I'd have technically 2 shaded regions. So my first shaded region right here, I would go with the integral from negative 1 to 2 of top minus bottom. Now the purple line's on top, so that's x minus 1. Minus the bottom parabola, so that's a negative already, so that would really be a plus root negative x plus 3. Okay, plus, now I'm going to do this second shaded region. So that shaded region goes from 2 to 3, top minus bottom. So the top line right here is this top parabola, so that's the square root of negative x plus 3. Minus the bottom parabola, so minus a negative, that's really a plus negative root x plus 3 dx. And we can use our calculator. We could plug both of these intervals in, and we can solve by adding them up. So that's one way to do it. I'm going to show you the other way to do it, which tends to be a little faster. We can also integrate with respect to y. So how that looks is if I turn my paper sideways so that my y-axis is on the bottom instead of the x-axis, you can clearly see that we have a top and a bottom. We have the top part of our graph, which is the parabola, and we have the bottom part of our graph, which is the line. And if I integrate with respect to y, I don't have to use all these different formulas, right? We already know what x is. This parabola is 3 minus y squared. And then the straight line is y plus 1. And we know our boundaries, right? On the y-axis, we're going from -2, right? We still start with the lowest number, to 1. So to make this a little easier, I can use y instead. And I would go from -2 to 1 of top minus bottom. Now when I turn my paper sideways, the parabola was on top. So in terms of y, the parabola is 3 minus y squared. And when I turned my paper sideways, the straight line was on the bottom. So minus y plus 1. Now instead of dx, we put a dy. Now the great thing about using our calculators, we don't have to use our calculator. We could take the integral of this pretty easy, just working from left to right. But I just want to show you something on your calculator as well. Your calculator doesn't know what variable you're using. So when we plug this in our calculator, I can still use x. My calculator doesn't know it's really a y. So I'm going to go to math, down to integral number 9, and I'm going to plug it in exactly how I see it, -2 to 1. And I've got 3, and I'm going to use x, 3 minus x squared minus x plus 1. It'll work if you use y too. You just have to put a dy over there as well. And I get 4.5, or 9/2. And you would have gotten the same exact answer up here with this long problem with the x's. So it's up to you how you want to do these. It doesn't matter to me. It wouldn't matter to a math professor as long as you set it up correctly and solve correctly. So you want to make sure whatever way you do it, your integrals are correct. That's the most important part. So sometimes it'll be easier to just turn your paper if you definitely have a function that's on top and a function that's on the bottom. Some of you just might like to stick to the x, but you'd have to use 2 separate shaded regions for that one, because here you can't tell which one's on top. It kind of switches. The purple line's only on top of the shaded region for this first little orange section. Then after that, it's not even a part of the shaded region. Okay, let's try number 2. We have a region bounded by the graphs of x to the third minus 2x plus 1, -2x, and x equals 1. So I'm going to use my calculator, get that plugged in, clear out my old graphs. Okay, so I've got x to the third minus 2x plus 1, and I've got -2x. And I can't do the x equals 1. You could if you want to draw the line, use your draw feature, but I know what it looks like, so I'm not going to do that. So we've got a cubic function. We should get a straight line here. And then I've got another straight line. So I'm going to draw a sketch of this on my paper. So I already know what 1 looks like, x equals 1. I'm going to draw that one in first. I've got -2x. And my third line, I've got a parabola. Now, before I sketch this, I'm just going to make sure I can see where they cross. So I'm going to do my second trace intersect, see where these lines cross. I'm going to go between the blue and the red. And, oh, a nice point. It crosses at -1, 2. So I'm going to plot that. And let's see, I'm going to see if this touches down right at 1. Oops, graph. I'm going to use my table. Probably be the fastest way. So, yep, it crosses at 0, 1, or 1, 0. Okay, so I'm going to draw a little sketch here on my paper. Doesn't have to be beautiful. And we're looking for the region bounded by those 3 lines. So we're looking for this little region right in here. And I can clearly see that I have a top and a bottom. The top of this shaded region is the red line. The bottom is the purple line, and the blue line is just a boundary, so it's the right boundary. The left boundary is right here where these two lines cross. So we're going from -1 to 1 would be our boundaries. So when I set this up, I'm going to go from -1 to 1, top minus bottom. So the top would be my red line, x to the third minus 2x plus 1, minus the bottom, which would be my -2x. That really turns it into a positive 2x dx. So this one, let's solve it without our calculator just to practice taking some integrals. So first thing I'm going to do is just simplify this for myself. The 2x's cancel, so that's x cubed plus 1 dx. Now I'm going to take my integral, so I'm going to add and divide. So that's 1/4 x to the 4th plus x. And we're going to evaluate from -1 to 1. So when we evaluate, we do top minus bottom. So I'm going to plug the 1 in first. 1/4 times 1 to the 4th plus 1 minus, I'm going to plug the -1 in next. So 1/4 -1 to the 4th power, and then plus the -1, so I'm just going to write that as -1. Okay, so over here, that gives me 1/4 times 1 plus 1. This gives me 1/4, but it's really -1/4 when I distribute that. And this gives me, plus 1. So the 1/4s cancel. 1 plus 1 gives me 2. Okay, so this ends our lessons on finding the area between two curves. Really, the last two questions that we did today, they're more of the difficult ones that you might find, especially when you might have to integrate with respect to y. So if you want to rewatch that one a couple times, that might be a good idea if that one was a little confusing. Other than that, if you have any questions, just let me know.